Have you ever stopped to wonder how your entire digital life, all of it, can run on something as simple as an on-off switch? Well, today we're pulling back the curtain on Boolean algebra. It's the secret language that powers literally everything from your phone to massive supercomputers. I mean, it seems impossible, right? Every video you watch, every message you send, all of it is built on just two super simple ideas: on or off, true or false, a 1 or a 0. So how on earth do you get from a basic light switch to something like a smartphone? That's the big mystery we're going to solve together today. So how do we bridge that huge gap? Well, the secret isn't about adding more complicated stuff. It's actually about having a really powerful set of rules to manage this simple stuff. And that rule book has a name. Say hello to Boolean algebra. It's basically a system of logic where everything, and I mean everything, is either a 1 or a 0, true or false. There are no maybes, no sort ofs. It's this simple black and white system that gives us the tools to combine all those ones and zeros into the complex instructions that make our devices actually do things. Okay, so if Boolean algebra is a language, it's got to have words, right? A vocabulary? Well, it does. And you're not going to believe this, but the entire digital universe is built using just 3 basic words. We call them operators. And here they are, the big 3: and, or, and not. Yep, that's the whole list. Every single action your computer takes, from the biggest calculation to the tiniest pixel change, is just a combination of these 3 simple ideas. So let's see what they actually do. Okay, so check these out. These are called truth tables, and they're basically the cheat sheets for our new language. Let's start with and. Think of it this way. You need your keys and your wallet to leave the house. If you only have one, nope, you're not going anywhere. You need both to be true, or 1, for the final results to be 1. Now, or is a little more relaxed. You need a passport or a driver's license to get on a plane. As long as you have at least one of them, 1, 1 in the input, you're good to go. And finally, we have not. It's the simplest of all. It's a rebel. It just flips whatever you give it. If something is true, not makes it false. A 1 becomes a 0, and a 0 becomes a 1. Simple as that. All right, so we've got our 3 little words: and, or, and not. Now let's see how we can start stringing them together to make sentences, or what computers call functions, that can actually get some real work done. You can think of a Boolean function kind of like a recipe. It's got really simple rules. You take your ingredients, which are just your variables, our 1s and 0s. You combine them using our operators, and, or, and not. And it gives you one single, totally predictable result. It's always going to be either a 1 or a 0, no surprises. Whoa. Okay. I know this looks like a lot, but stick with me. Let's just break it down together. Just like in regular math, there's an order of operations. We always do the nots first, then the ands, and then finally the ors. So let's just look at that very first row, where x, y, and z are all 0. First up, we see not z. Well, z is 0, so not z flips it to a 1. Easy. Next is the and part, x and not z. That's 0 and 1, which gets us 0. Then finally the or part. We take that result, 0, and or it with y, which is also 0. So 0 or 0 gives us our final answer, 0. See? It's just a logical, step-by-step process that always works. All right, this is the big moment. This is where it all clicks into place. We've seen all this abstract math, but how does this stuff become the actual phone in your hand or the laptop on your desk? Why should you even care about any of this? Well, here's where the magic really happens. Every single one of those Boolean functions can be built as a physical circuit inside a microchip. And the simpler you can make the function, the simpler the circuit. And a simpler circuit, well, that means faster, cheaper, and way more efficient technology for all of us. And this is exactly why engineers spend so much time trying to simplify these things. Simpler circuits are physically smaller, so they're cheaper to make. They use less electricity, which means, longer battery life for our devices, something we all want. And because the electrical signal has less junk to travel through, they run so much faster. It's a total win-win-win. So how do they get all those benefits? They're not just guessing. Engineers have this amazing toolkit of rules they can use to chop down complex Boolean functions into something much simpler. And these aren't just abstract ideas. They're the practical, hands-on tools for designing better electronics. Now, don't worry, some of these rules are going to look super familiar. The commutative law just says order doesn't matter. X and Y is the same as Y and X. The associative law says it doesn't matter how you group them. These work exactly like the basic math we all learned back in school, which is kind of nice.
But then you get some, let's call them special rules, like the absorption law and the incredibly powerful De Morgan's law. Honestly, De Morgan's law is like a secret weapon for circuit designers. It's this really clever trick that lets them swap an AND gate for an OR gate, or the other way around. Now, that might not sound like a huge deal, but trust me, in the world of microchip design, that can lead to massive simplifications, making everything smaller, faster, and way more efficient. And, that really is the main idea to take away from all this. All the incredible, jaw-dropping complexity we see in our digital world, from AI to photorealistic graphics, it is all fundamentally built on this ridiculously simple foundation of true and false. Everything else is just the result of applying these simple rules over and over again in really clever ways.
It really makes you wonder, doesn't it? The binary system, this whole world of ones and zeros governed by Boolean algebra, was a fundamentally simple idea that completely reshaped our planet. So it leaves us with a pretty big question. What's the next beautifully simple idea out there, just waiting for someone to find it, that could change everything all over again?